We are going to understand the dynamic programming. The first thing based on this problem called change making, or simply called point change. Before this, we found this problem discussed under the brute force design strategy, in particular under the exhaustive. So from the brute force design strategy for this problem coin chain, so the first step, we need to have a two-step. The first step is to list out all feasible solutions. I mean the combination based on the coin here that say we have the amount of 6 cent and here, and given then denomination 1%, 3 cent and 1 cent. And the goal is try to obtain the least number of coins. Okay, from the brute force we have to list out all possible here feasible solution based on denom percent, denom 3 cent and 1 cent in order to find that the least number. Right, the next step, when we have the list of the solution, feasible solution, the next step we just choose the optimum, mean the least number of coin. For the for the greedy designs strategy, so the goal is the list of number of coin. So the idea is very simple. We start with the highest value of the denom, for example here percent, and after the second, the third here. And with that, the idea is we would obtain the least number of coin. Look at this. For these problems given to us, sent here. So at the end, when we apply the greedy design setting, so we obtain 1 coin for the percent, 2 coin for the percent. So altogether 3 coin, 3 coin here. So the issues now is this the optimal solution? Absolutely no, because the optimal solution is 2 coin. We can take that the 3 cent and 2 coin of 3 cent. So this is actually the optimal solutions. So greedy solutions may not be optimal for arbitrary coin denomination. This is one of the main problems or limitation or drawback of brute force, of design, greedy design technique. Let us take a look this the same problem applied by using dynamic programming. So the same example where we have a denom 4 cent, 3 cent and 1 cent with 6 is our amount ends here. So under the dynamic programming, the overall idea in general basically, we try to find the smaller instant solution. When we solve it, so we keep it, we record it, and later if we have the same uh, problem and the same solution can be applied, just make use of it. For example here, this is actually the small. If n equal to 0, of course it is a 0 coin here. When n equal to 1, we have denom 1 here, so of course 1 here. Okay, when n equal to 2 here, so we can have this function f2 minus 1 equal to 1. We try to find minimum. Since only 1 here, you return 1 here. So we have already, it has already solved here. N equal to 1 is 1. So we return 1 plus 1, 2 here. For the n equal to 3, so 3 minus 1, 2. 2 here, we have already the solution here, return 2. And 3 minus 3, 0. We have already solved for the 0 here. So the minimum 2 and 0, return 0. And 0 plus 1, 1. For the 4 here, we have a denom 1, denom 3, and denom 4 here. So 4 minus 1, 3. 3 is we have already solved the 3, return 1. And 4 minus 3, 1, 1, return 1 here. and 4 minus 4, 0. So 0 returns 0, so the minimum is 0, 0 plus 1 is 1. Next is number 5. Number 5 here, n equal to 5. 5 minus 1, 4. We have already solved here. The solution is 1, so we return 1. 5 minus 3 is a 3. We have already the solution here, and return 1. 1 return 1. 5 minus 3, 2. 2 return 2 here. That's why we obtain 2 here. 5 minus 4, 1. Return 1 here. And the minimum is 1. 1 plus 1 is 2. And finally, n equal to 6. As per our example just now. 6 minus 1, 5. We have already done for 5. Return 2. 6 minus 3, 3. We have already the solution for this 1. And 6 minus 2, 2. So we got 2, 1, 2. And this is the minimum. 1 plus 1, 2. And finally, we can obtain for each of the n here, 0 to 6 here, where our aim is a 6 here, we obtain 2. This similar we obtain for the optimal 2 coin of denom instead of the greedy 3 coin here. This is the optimal solutions for the chain making problem solved by dynamic programming design strategy.